Hello all. So today we are going to discuss Python. So Pythagoras theorem is applicable only on right angle triangles. So let's draw our right angle triangle with sides ABC. So right angle triangle is any triangle with one of the corners at 90 degrees. And the side opposite to that 90-degree corner is called the hypotenuse. So in our case, it would be C. C would be our hypotenuse. So as per Pythagoras theorem, C square is equal to a square plus b square. That is sum of the square of the hypotenuse is equal to sum of the squares of the other two sides. Okay. So now to prove this theorem, we need two prerequisites. First is area of the right angle triangle. So area of the right angle triangle is given by half of base into height. This also can be half a into b. You can take anyone as base and anyone as height as long as the two sides are the sides that are creating the 90-degree angle. So A can be base, B can be base. It's okay. Half into A into B is equal to half into B into A. The second prerequisite would be to understand that it doesn't matter what is the orientation of the triangle. Okay. As long as we are keeping the sides as A and B, not changing the values of A and B, the third side will automatically come out to be C. So what I mean is if we suppose take this as A, this as B, this will automatically come out to be C. We can take this like this also. If this is A, this is B, third will automatically come out as C only. It won't be like this is C1, C2, and C1 and C2 is some different value. No. As long as A and B are same, the C1 would be equal to C2 always. And the angles between A and B should be 90 degrees. Okay. So with these two prerequisites, I will now try to let me clear the screen. Now with these two prerequisites, we will be able to prove the Pythagoras theorem. Let's get our right angle triangle again with sides A and B, hypotenuse C. Now let's do some construction. We will extend the side B till A. Okay. Then we will draw B. And if I join these 2 points, as we saw earlier, this will automatically turn out to be C. We will say we will do the same thing on the bottom side. So if this is B, let me draw it straight. Okay. This is B. This is A. This will turn out to be C. Same thing here. This is A. This is B. This will turn out to be C. Okay. Now let's do some labeling of the corners. So this corner would be capital A, capital B, capital C, and capital D. Let's label this corner as E, F, G, H. Okay. Now what all things can we observe? The first thing that we observe is if we go from A to B, right, we will get the distance B plus A. If we go from B to C, we will again get B plus A. If we go from C to D, we will again get B plus A. Similarly, from D to A, we will again get B plus A. So we can say that all the sides of the square ABCD, let me create some space, it's getting crowded. So all the sides of the square, capital A, B, C, D, are of the length A plus B. So area of this square would be A plus B whole square. Okay. This can be our first equation. Second equation is area of EFGH. That would be simple. It is C square because you can see that in that square each side is of C. Third thing would be area of the small triangles. So if we see one of the triangles, let's see this one in red. We see that its base is A, height is B, or base is B, height is A, doesn't matter, this is 90 degree. So its area would be half of A into B. So total there are four triangles like this and each one has sides A and B. So the total area of the triangle, I will call this total triangle, is equal to 4 times half A into B. This would be equal to 2AB. Now we know that area of ABCD from equation 1 is A plus B whole square. This constitutes of the smaller rectangle, smaller square, and the four triangles. So area of the smaller square is C square, and the area of four triangles total is 2AB. We expand this, we will get A square plus 2AB plus B square is equal to C square plus 2AB. We can cancel 2AB from both sides. Then we get A square plus B square is C square, and that is our Pythagoras theorem. So if you observe, what we did is, this is proof by construction. Okay, our original triangle was this one, and we did not change its dimensions at all. So the property of that original triangle will remain same. We created construction outside of it like this, and through our observation of areas, we calculated a property related to our original triangle. That turned out to be C square is equal to A square plus B square, which is our Pythagoras theorem. So I hope you all were able to understand the Pythagoras theorem and its proof. Maybe in the next video we will talk about the practical applications of Pythagoras theorem. So thank you for watching this video and have a great day ahead. Thank you.